coordinate voltage control with VAR control. It's called integrated volt-VAR control, IVVC. Okay? We'll talk more about renewables, integrating renewables onto the grid. We're putting more sensors out on the grid. We're getting more information back. Okay? And the reason is there's been a lot of investment in transmission and generation, but not as much investment in distribution. I don't know, it'd be interesting to know what the situation is here in Tunisia, but in the United States, we have 15,000 transmission substations, and every one has full automation, every one. We have 52,000 distribution substations. Only 2/3 of those have automation. Okay? 1/3, we say the 1/3 are unobservable. When we're in the control center, there's no information coming back from those substations. So if your house is fed from one of those substations and you lose electricity, the electric utility doesn't know until you call them, okay? Because they have no automation in those substations. There's a lot of work today in adding automation to more substations, okay? But this sensor here is for a transformer. The average age of many transformers today is very old, okay? So the probability of a failure is high. In the United States, the average age is 42 years old. In the United Kingdom, it's 38 years old, okay? When a transformer fails, it's an asset that's very expensive, right? Several $1 million. When it fails, we call it a catastrophic failure. It's a catastrophe. Like that. That was perfect. The transformer does that, but it's much louder. That was perfect. Whoever did that, that was perfect. Catastrophic failure. This is we had an outage, and we had a failure. So, when a transformer fails, it explodes, and pieces of metal they destroy the whole substation. So it's very expensive. I can spend a little bit of money. I can put that sensor on the transformer. I take the oil from the main tank of the transformer. I put it through this sensor, and I can detect up to 9 different gases dissolved in the oil. Okay? And if I see like ethylene gas in the oil, that tells me a specific failure mode that's occurring in the transformer. Methane is a different failure mode. So it's very important we do dissolved gas analysis called DGA. So the object today is, what we used to do was when something failed, then we went to fix it. What we want to do today is put sensors on the assets, know what the health is, and predict what's going to happen. We want to fix things before they fail, right? Predictive, not reactive, but proactive, right? Then we're adding new control centers on distribution. When we integrate renewables on a distribution system becomes very complex, okay? And we need a separate, we call it SCADA. How many of you, do you know the term SCADA? Supervisory Control and Data Acquisition. It's a fundamental system for any automation. Supervisory control means remote control, and data acquisition means I'm acquiring data from the field, okay? And then we're doing automation on the feeders, and we're implementing smart meters, okay? So let's look at the concept of a solution. So these 6 solutions have the strongest business case to electric utilities in the world. One is optimizing assets. The first asset is transformers. Second is circuit breakers. Very important circuit breakers. High voltage and medium voltage. Okay? Then we look at load, demand. Okay? We aggregate, we sum up load to a large level, and we can use that as a dispatch tool. We implement smart meters and the two-way communications with smart meters. We optimize distribution. This here, that's the strongest business case today of any of these solutions, right here. For every dollar I spend on distribution, I get $5 to $6 back. So we say the benefit to cost ratio is about 5 to 6 to 1. Okay? So when we do a financial analysis of a technical project, you want to say, what will it cost? What benefits will I receive? What's the benefit cost ratio? And what's the payback period? How many years will it take for the benefit curve to cross the cost curve, right? Because your senior manager at your company will say, how much is it going to cost? What benefits will it provide? And what's the payback period? You can have a very good benefit cost ratio, but if the payback period is too long, it's not a good investment. It might be 10, 12 years. Okay? We're optimizing transmission. Here we're doing a lot with synchrophasers, phasor measurement units, wide area measurement systems, and then the workforce. Okay? The reason it's important with the workforce is, as I said, our industry typically has a lot of senior people, okay, that are retiring. And in the United States, we have 40% of all the workers in the energy industry. 40%, not just engineers, but all the workers. 40%, and 60% of the executives will all retire in 5 years. That's a lot of knowledge, experience, and people. And the amount of work we have to do is increasing. Okay? We need qualified young professionals in the power field. Okay, and I'll give you an example is, if you have the right qualifications, companies like GE will actually bid on you with a signing bonus. Okay? So 11 years ago, when my son graduated from Georgia Tech with 4 internships in power and taking 2 power courses, he had GE and Commonwealth Edison, an electric utility in Chicago, bidding on him. They kept increasing the signing bonus amount, and when he accepted the offer from GE, he received a check for $9,000. And all to get the $9,000, he said, "I accept your offer." Okay, because when companies find qualified I mean work experience and taking the right courses, choice of courses. Companies will pay extra for you to work there, okay? So workforce is very important. If we take those solutions and we do a technology roadmap, the question is, what technology components are involved in the solution, and where are they located on the grid, okay? So these are components in the office or the control center. These are in the substation. These are out on the feeders. This is the customer, and this is the communications, and this is the utilities field people, the mobile, okay? So let's look at distribution, the strongest business case today. These are software applications. All the light blue boxes are distribution. Software, systems, substation equipment. We have a distributed architecture today, so we have logic at the control center, at the substation, and now we have logic at the edge of the grid. I'll show you that in a minute. We call them grid edge controllers, okay? So we can run applications at the substation level or at the control center level. I need switches on the feeders because the logic up here, fault detection, isolation, restoration. When I detect a fault and I want to isolate the fault, I need to open a switch on each side of the fault. And that's what these switches, so here's the logic and here's the equipment on the feeders. Here I have capacitors and voltage regulators. So when I do integrated volt-var control, here's the logic, and these are the equipment on the feeders. Or the logic could be here. Okay? So let's say you're in charge of a project, then you have different vendors, different manufacturers, giving you all these blue boxes.